Inside a Node.js process, JavaScript execution runs on a single main thread by default. Node.js does provide worker threads. When explicitly created, additional JavaScript threads can run in parallel inside the same process. But even with that capability available, a single Node.js process does not automatically utilize multiple CPU cores. So how does Node.js scale across all CPU cores of a machine? Let's break it down. When you run nodeserver.js, you create one operating system process. That process contains one V8 instance, one event loop, and one main JavaScript execution thread. Unless worker threads are explicitly created, all application logic runs on that main thread. The operating system schedules that process on a CPU core. If your machine has 4 CPU cores, a single Node.js process will not automatically use all 4. Node.js does not split one event loop across multiple cores. So to fully utilize the machine, we replicate the process. We run multiple independent Node.js processes. Each process has its own memory space, its own V8 instance, its own event loop, and its own main execution thread. The operating system scheduler dynamically distributes these processes across available CPU cores. Processes are not permanently bound to specific cores. The OS assigns CPU time slices as needed. With 4 cores, we can run 4 Node.js processes in parallel. This is process-level parallelism. Node.js provides the cluster module for this. The cluster module creates a primary process. The primary process forks independent child processes using cluster.fork. Each child process runs the application code independently and handles incoming HTTP requests. In a typical production setup, the primary process does not run the HTTP server itself. It supervises and coordinates, while the child processes handle request processing. By default, connections are distributed among child processes using round-robin scheduling on most platforms. Cluster is one way to scale across CPU cores, but it is not the only approach. In many production environments, scaling is handled outside the Node.js application. Instead of using the cluster module, we can run multiple independent Node.js processes and place a load balancer in front of them. The architecture looks like this. Client connects to load balancer, which distributes traffic to multiple Node.js processes. Each process runs independently. The load balancer handles traffic distribution, while each Node.js process focuses entirely on handling requests. This approach moves scaling responsibility from the application layer to the infrastructure layer. Now clearly separate two concepts. Worker threads enable parallel JavaScript execution inside a single process. They are useful for CPU-intensive tasks. Multi-process scaling increases HTTP request capacity by running multiple processes across CPU cores. Worker threads improve computation throughput. Multiple processes improve request handling capacity. Different layers, different goals. In production, tools like PM2 simplify this. When you run PM2 start server.js-imax, PM2 starts multiple Node.js processes. In cluster mode, it uses Node's cluster module internally. A primary process supervises child processes, while child processes handle HTTP traffic. On a 4-core machine, PM2 can run 4 application processes in parallel. One critical rule remains: never rely on in-memory state. Each process has isolated memory. If sessions are stored in memory, different processes cannot share them. Scalable systems externalize shared state, using Redis, databases, or dedicated caching systems. So to summarize, JavaScript execution inside a process is single-threaded by default. But Node.js scales across CPU cores by running multiple independent processes. The operating system schedules them across cores. Traffic is distributed through cluster or an external load balancer. And shared state must live outside the process. That is how Node.js scales across multiple CPU cores. Not by changing JavaScript's execution model, but by designing the architecture correctly. If you enjoy clear explanations of complex system concepts, subscribe for more.